In section 5.9, we further solving fractional equations. And if you notice from section 5.8 that the denominators are a little bit more complex. Here we have quantities. We're talking even variables. And so it takes us back into section 5.7, 5.6, when we were working with common multiples when you have quantities or variables in the denominator. But what we do in section 5.9 is exactly what we did in section 5.8. We look at what is a common multiple. So in problem number 1, these are represent two different values. So our common multiple is y minus 1, y plus 1. And just like in section 5.8, we go through and multiply each term times the y plus 1 minus y minus 1. And then this way we are taking out the denominators. So I have 5 times y plus 1 minus 4 times y minus 1, and then 0 times this would be equal to 0. So I have 5y plus 5 minus 4y plus 4 is equal to 0. Y plus 9 is equal to 0. Y is equal to negative 9. Now, if you notice up at the top, I wrote always check your answer. And here's the reason why. Is we can go and put this in for y and make sure that it works. But we also have to make sure that the denominator does not give us 0 if we put negative 9 in. And here, if I look at y minus 1 and y plus 1, the two values that would make that either of those 0 would be 1 or negative 1. And so y equal to negative 9 is a good result. Okay, so example number 2, always, always, always factor first. So x minus 1, x plus 1. So our common multiple would be x minus 1, x plus 1, and we would go through and multiply each of these terms times x minus 1, x plus 1 to get rid of the fraction. So x minus 1's cancel, and I'd have 2x plus 3 times x plus 1. The x plus 1's cancel, so we'd have 2x minus 3 times x minus 1, and then these will all cancel and give us 10. So if we go through and FOIL this, we end up with 2x squared plus 5x plus 3. I've kind of jumped there. And if we go through and FOIL this, we end up with 2x squared minus 5x plus 3. But we have this minus out here in front of that. And so if I go through and distribute this negative 1, I end up with a negative 2x squared minus 5x minus 3 is equal to 10. Putting that together with the 2x squared plus 5x plus 3, we have some values that are going to, this is supposed to be a plus, cancel each other out. So we have 10x is equal to 10, so x is equal to 1. Double checking to make sure that it does not put a 1 or a 0 in the denominator, and actually it does put a 0 in the denominator. If that's the case, then I can't use this, and this would be a no solution. Example number 3, the common multiple would be x and x plus 1. So going through and taking it times x plus 1. The x's cancel, and so I would have x plus 1 out of my first grouping. These would cancel and leave me a plus 4x. And then here I have 6x times x plus 1, so that's 6x squared plus 6x, 5x plus 1 on the left-hand side. If I get it set equal to 0, I have 6x squared, subtract the 5x, subtract the 1. So if I go through and factor this, it's going to factor as 3x minus 1 and 3x plus 1. So my values possible for x are 1/3 and a negative 1/2. And going back up to my original equation, I can't have a 0 and a negative 1, so these two values are good. Okay, if you want to give number 4 a pause and work through it, I will work through it. Otherwise, work through it with me. Factoring the a squared minus 3, or 9, it would be an a minus 3, a plus 3. And that's our common multiple. So if we go through and multiply times a minus 3, a plus 3, these are going to cancel. Both of these are going to cancel. And this is going to cancel. So I would end up with an a plus 3 plus 2 is equal to 5 times a minus 3. So a plus 5 is equal to 5a minus 8, or 15, sorry about that. So I'm going to have a negative 4a equal to a negative 20. So a is going to be equal to 5. And if I take a look up there, I should be okay with a is equal to 5. Okay, last example. The very first thing we would want to do is go through and factor, and u plus 3, u minus 2 is going to be my multiple that I'm going to multiply through times. And these are all going to cancel for the first term and leave me 5. The u minus 2 is going to cancel and leave me u minus 3 times u plus 3. And then this is not going to cancel. And I'm going to have to multiply all of that out. So on the right-hand side, I get 2u squared plus 2u minus 12. And on the left-hand side, I get u squared minus 9. So that's u squared minus 4. Okay, let's get it set equal to 0. So subtracting the u squared over, I get u squared. And adding the 4 over, I get a minus 8. So I have u plus 4 and u minus 2. So a negative 4 and a positive 2. If we go back up and look at our denominators, the 2 will not work, but the negative 4 will. So I have one answer for that. Let's talk about the word problems. Now we're only going to go through 2 word problems in section 5-9. And the first one says find 2 positive numbers. So we have 2 positive numbers, let's say x and y, whose sum is 12, and the sum of their reciprocals is 4/9. Okay. So if I go through and solve for x here, what I have is 1 over 12 minus y plus 1 over y is equal to 4/9. So my common multiple is 12 minus y times 4. Or times 9, sorry about that, times 9. So we have 12 minus y times 9. So as we go through and solve, we end up with 9y plus 9 times 12 minus y is equal to 4y times 12 minus y. So 9y plus 108 minus 9y is equal to 48y minus 4y squared. Those are going to cancel. And if I bring everything over to the left-hand side, I end up with this equation. I can factor out a 4, which is 27. And this is going to factor to u minus, or y minus 9 and y minus 3. So I have two different values for y, 9 and 3. And again, just like we did back in chapter, I believe it was 4, if you have 9 for y, you get 3 for x. And if you get 3 for y, you get 9 for x. So you only have one combination, and that's 9 and 3. The other example comes off of something that we did in section 4.8. And in section 4.8, we talked about when Stan and Chris are loading together. But in this case, we're given what one can do by itself, and we have the one where they are working together, and we're asking how long does it take them alone. Okay, and remember that we set up this this chart, and we had a rate times time is equal to the work that is done. Okay, now when we talk about Stan's rate, his rate per 1 minute is 1/24th. But we don't know what Chris's is, so I'm going to put 1 over C. The time here is time together, and they give that to us, 15 and 15. And so when we multiply that, I end up with 15/24ths, and I have 15 over C. So the contrast of what we did in 5.8 is this was our unknown, and we knew these two fractions. So when we take the work individually, and actually I can reduce this down. I can reduce it down by, what, 3? So I have 5/8 plus 15C is equal to 1. Common denominator is 8C, so our common multiple, if we go through and multiply through here, this is going to cancel and give me 5C. The C is going to cancel and give me 120 is equal to 8C. So 120 is equal to 3C, so the C is equal to 40 minutes. So Chris can do it in 40 minutes. Stan can do it in 15 minutes, or 24 minutes, and together they can do it in 15 minutes.